Okay, for question 2 on the Hawkeye quiz, the first part, he's just ranging it and he's standing, it goes up and comes back down in a full-on parabola. This would be the kind of drawing that I'd be looking for here. The question states that he fires it at a 45-degree angle, so it's going for its maximum distance. You'll remember that maximum distance from a projectile happens when you fire it at 45 degrees. This is what I would be looking for. Make it easy on yourself. Always with these things, half of this diagram is a mirror of the other half. So I've got a dot over here. I'll put a dot over there. I've got an arrow going up. If I was drawing this with a ruler, I would make sure that this arrow going down was just as long as this arrow going up. The arrows going up get shorter and shorter and shorter until the very top. There is no arrow going up. And then as it starts coming back down, the arrows go down, but they're the same size as their counterparts over here. And then, of course, your resultant vector that I'm interested in, that you understand, would be something like this, where it would, a little bit closer to the axis there. What I'm trying to show is this thing has, I should curve my arrows. If I follow through my blue arrows, yeah, it's green arrow's cousin. If I follow through on my blue arrows, I should pretty much be able to see the flight of the arrow pointing tail to tip to tail to tip as it goes across, or tip to tail, tip to tail. That's what I would be looking for. Again, this part right here, as always, Vx, no change. They should always look the same. I'd appreciate if you're doing this on corrections that you make kind of what I did here, that you make your resultant vector a different color than your horizontal and your vertical. And make sure you understand what you're doing and what you're showing here. So that's for the first part, just the diagram of it all. Let's get cracking on the problems. 2b asks how far the arrow has flown, but it's something that you would call a trick question because you can't figure that out without going to question C, which is how long? How long was it in the air? To figure that out, of course, you need time. Once you figure out time, you can figure out how far it flew. To figure out time, I'm going to use our old friend delta y equals 1/2 at squared plus vit. Now, this is one way to do this. There are other ways around this, but this is just what I see as the easiest way to do it. I'm basically figuring out how long the arrow took in its change in y. You figure out what the arrow's change in y was. It goes up. It comes back down. So our delta y, or difference between start and end position, is 0 meters. So that makes it kind of easy to work out, and it doesn't mean we have to use a quadratic. Don't get all panicked on me here. So I'll put in 0 equals 1/2 a, that would be gravity of negative 9.8 times time squared plus VIT. VI. I have no idea what VI is. So I have to go back and tear apart this thing. I'm going out at 125 meters per second. And down. Right here is 45 degrees. I can figure out those x and y components by using my trigonometric functions. If I want vi sub y, I can just say vi sub y equals 125 times the sine of 45, which equals 88.75. vi sub x equals 125 times the cosine of 45, which is, surprisingly, 88.75. These are meters per second and meters per second. When you're doing this for corrections, if you are, I want more detail. I don't want this just cut right here to this. I want you to show me how you got that, of how you were able to shorten this down to VIY equals 125 times the sine of 45. So I've got my VI now. I put it in here, 88.75 times T. Do my math. This is going to give me negative 4.9 T squared plus 88.75 T. 4.9 T squared, adding 4.9 to both sides, equals 88.75 T. Then divide both sides by T. I get 4.9 T equals 88.75. Divide both sides by 4.9. T equals 18.11 seconds. That is how long it takes the arrow to go up and come back down. That is its total flight time in the vertical, up and down. But remember, these things are linked by time. So while that is the answer to C, I can take that back to B, where I want to know how far it traveled in that time. Well, delta X equals 18.11 times my horizontal component, which is constant. So my distance equals my time times my velocity. It is 88.75. 18.11 times 88.75. I got about 1607.3 meters. So that arrow flew over a kilometer away from Hawkeye when he sent it up. So B has to be solved after C. C allows you to figure out how long it's going to take. B, then you go back and figure out how far it flew. We got one more part, and it's pretty easy. Question D is asking, what is the arrow's maximum height in its flight? Well, to figure that out, we need to go with time again. The time it took for the arrow to fly the whole distance, let me get this back up there. The time it took for the arrow to fly the whole distance, remember, was 18.11 seconds. How long does it take to go to the top of its flight? Well, half that time. So 18.11 divided by 2 equals 9.055. Again, I'm not caring about significant figures. So that is how long it takes to go to its highest point, from where it was fired to its highest point. So I want to know how high up it was at its highest point. Our old friend. Delta y equals 1/2 at squared plus vi times t. 1/2, again, negative 9.8 t squared. That's 9.055 squared plus vi, again, from last step, that was 88.75 times t, 9.055. Do the algebra. This is going to be one big negative number. This is going to be one big positive number. Subtract this negative from your positive. Some folks I did see forgot that this was a negative and just added them together. It shouldn't be crazy big. It's going to be pretty big for an arrow. I got about 401.86 meters for my delta y. Goes up a little under half a kilometer. But then again, it's Hawkeye and he's a superhero. Again, when you're doing corrections on all of this problem, I want to see more intermediate steps. I don't want to just see exactly what I have here. I left some steps out on purpose, and that's what I'll be looking for when you are solving yours. Hopefully it should take you the time to put those intermediate steps in. It shouldn't be just like, what does he mean by doing intermediate steps? So that's what I want to see. You know the due date on this. Get it back in. It can lift you up as high as a 90 on it. If you did not do this quiz in the first place, do this, get it in. It'll get you as high as a 70.